Welcome back to Tech Curiosity Stream, where we break down the tech shaping our world. Today we're diving into a buzzword you'll hear more and more: edge computing. It sounds technical, but by the end of this video, you'll get it and see why it matters. We'll start with the cloud, then show why it isn't always the answer. No jargon, just real-world examples and simple analogies. My goal: next time you hear edge computing, you'll know what it is and why it's changing everything. This isn't just for engineers. If you use tech, this is for you. The way our devices process data is shifting, and it's moving closer to you than ever. Let's demystify edge computing together. First, why should you care? Why care about edge computing? Because it's about making your tech faster, smarter, and more reliable. Most of our digital lives depend on the cloud, distant servers handling our data. That's fine for streaming movies or saving files, but what about when every millisecond counts? Imagine a self-driving car or a doctor using a robotic arm. Waiting for the cloud isn't fast enough. The cloud's distance creates delays, and as we connect billions of devices, sending all that data far away just isn't practical. We need processing power closer to where data is created. That's the promise of edge computing. Smarter, faster, more independent devices. It's about overcoming the limits of today's tech. Edge computing is the next step in our digital evolution. Let's see how we got here. Before we get to the edge, let's talk about the cloud. The cloud is just massive data centers, giant warehouses full of powerful computers owned by companies like Amazon and Google. When you upload a photo or stream a show, your device talks to these distant servers. The cloud lets us use simple devices for complex tasks because the heavy lifting happens far away. It's made software accessible and data portable. You can start an email on your phone, finish on your laptop, and access it anywhere. The cloud is the backbone of the modern internet, but there's a catch. Your data has to travel a long way. That journey matters more than you think. Let's follow your data's path. Your data's trip to the cloud isn't instant. It travels a complex data superhighway. From your device, it hops through routers, cables, and switches, sometimes across continents. Each stop adds a tiny delay. For most things, like browsing or streaming, this delay is barely noticeable. But distance is a real factor. Even at light speed, data takes time to travel. Think of it like express shipping. Even the fastest delivery isn't instant. In tech, this delivery time is called latency, and latency is the key reason we need edge computing. Let's break down what latency really means. Latency is the delay between sending a request and getting a response. It's measured in milliseconds, and for most things, it's fine. But physics sets a hard limit. Signals can't go faster than light, and every router adds a pause. In online gaming, high latency means lag. Your actions register too late. It's not your device or the server, it's the distance. No matter how fast your internet, you can't beat the laws of physics. For many apps, latency is just a minor annoyance. But for the next wave of tech, it's a deal breaker. The cloud's biggest strength, centralization, is also its biggest weakness. So what happens when good enough isn't enough? The cloud works for most things, but some tech needs instant responses. Self-driving cars, Arkansas glasses, and smart factories can't wait for distant servers. For them, latency isn't just annoying, it's dangerous. Imagine a car waiting for the cloud to tell it to brake. By the time it gets the answer, it's too late. Augmented reality needs graphics to react instantly, or the illusion breaks. In factories, robots must coordinate in real time to avoid accidents. The cloud's distance is now a critical flaw. We need to move processing power closer to where data is created. That's the shift to edge computing, bringing intelligence to the edge of the network. And that's how we unlock the next generation of technology. We've hit a wall. Technologies like self-driving cars, Brawl Shot Group 3, Distribute_equally, and augmented reality are held back by the speed of light. If distance is the problem, why not reduce it? This is edge computing, bringing processing power closer to where data is generated, like your smartphone or car or a smart hub. It's decentralizing the internet's brain. We're creating a network of smaller, localized brains for urgent tasks. The central cloud remains important, but for split-second reactions, the work is done locally. By moving computation closer, we slash latency. It's moving to a more distributed model. Let's use an analogy. Imagine a huge city with one grocery store downtown. For a carton of milk, you drive downtown, deal with traffic, and drive back. This is cloud computing, powerful for big tasks, inconvenient for small needs. What if a convenience store opened nearby? It has essentials like milk and bread. Now, for one item, you walk down the street. This convenience store is your edge server. The edge isn't replacing the cloud. The cloud is for big tasks, but the edge server handles immediate tasks, providing a near-instant response. A security camera detects motion. The edge device analyzes it locally. It sends an alert only if something important happens, saving bandwidth. This is the power of a mini-cloud where you need it. So what does this new data flow actually look like? Let's trace the journey of data in an edge computing world, using our self-driving car. As the car moves, its sensors generate gigabytes of data every minute. An edge-enabled car has a powerful onboard computer, the first layer of the edge. It receives raw data and handles critical functions immediately, like identifying pedestrians and engaging the brakes in milliseconds. For less critical tasks, it connects to a local edge server at a nearby 5G cell tower. The cloud handles long-term big data tasks. Engineers use data from thousands of cars to improve algorithms and update the entire fleet. The cloud is essential for learning, while the edge handles the immediate act of driving. Edge computing isn't here to kill the cloud. They're two parts of an evolving ecosystem. Edge computing is an extension, not a replacement. It complements the cloud by addressing weaknesses, creating a more balanced system. The cloud remains the champion of massive computation and storage. The edge provides a crucial middle layer of intelligence. It acts as a smart intermediary. By processing data locally, the edge reduces traffic. It's a symbiotic relationship where each part makes the other better. It's a hybrid world where computation happens where it makes the most sense. Understanding this partnership is key to understanding the true potential of our connected future. The smart home is seeing edge computing make a real difference. You likely have a smart speaker, smart lights, or a video doorbell. Early smart homes relied on the cloud for almost every command, leading to delays. Now, edge computing enables newer smart home hubs to process commands locally. Voice recognition happens on the device itself, communicating directly with devices over Wi-Fi. This results in instant responses and continued functionality even without an internet connection. Edge-powered security cameras analyze video in real time, differentiating between people, pets, and cars. They only send notifications for important events, enhancing efficiency and privacy. Okay, let's move out of the house and into another place we're all familiar with, the retail store. Edge computing is quietly revolutionizing the shopping experience, both for you as a customer and for the store itself. It's making things faster, more personal, and more efficient. One of the most visible examples is the rise of grab-and-go stores like Amazon Go. In these stores, there are no cashiers and no checkout lines. You just walk in, pick up what you want, and walk out. It feels like magic, but it's actually a brilliant application of edge computing. These stores are covered in hundreds of cameras and sensors on the shelves. As you walk around and pick up items, this complex sensor network tracks exactly what you take. All of this video and sensor data can't possibly be sent to the cloud for real-time analysis. The delay would be too great and the bandwidth required would be insane. Instead, powerful edge servers right inside the store process all that information locally. They use sophisticated computer vision to identify you and the items you select, adding them to a virtual cart. The decision of what's in your basket is made right there, at the edge. This local processing is what makes the whole experience seamless. When you walk out, the edge system finalizes your virtual cart, charges your account, and sends you a receipt. The only data that needs to be sent to the central cloud is the final transaction summary, not the gigabytes of video footage it took to figure it out. This makes the system incredibly fast and robust. It also means the store can continue to operate even if its main connection to corporate headquarters temporarily goes down. The intelligence is right there in the building. Beyond checkout-free stores, edge computing is also powering other in-store innovations. Think of smart shelves that can track inventory in real time and automatically alert staff when an item is running low. Or consider personalized digital ads on screens that change based on general demographic data of the shoppers nearby, all processed locally to protect individual privacy. For retailers, this means better inventory management and less waste. For you, it means a smoother, faster, and more convenient shopping experience. It's all about using local computing power to make the physical world a little bit smarter. Now, let's get into something a bit more industrial, the world of manufacturing. Factories are complex environments filled with expensive machinery, robotic arms, and complex assembly lines. For these operations, efficiency and safety are everything. Even a few minutes of downtime can cost a company thousands of dollars, and a malfunction can be extremely dangerous. This is a perfect scenario where the instant response time of edge computing isn't just a nice to have, it's an absolute necessity. The modern smart factory runs on the edge. Imagine a factory floor covered in thousands of sensors attached to every piece of equipment. These sensors monitor things like temperature, vibration, and energy consumption. In a cloud-only model, all this data would be sent to a remote server for analysis, but by the time the cloud server detects an issue, say a machine is overheating, it might be too late to prevent a breakdown. With edge computing, a local server on the factory floor analyzes this sensor data in real time. It can spot the signs of an impending failure and automatically shut down the machine before it breaks, or alert a technician to the specific part that needs maintenance. This concept is called predictive maintenance, and it's a game changer for industrial operations. Beyond just preventing failures, edge computing allows for incredible coordination between machines. Robotic arms on an assembly line can communicate with each other with near-zero latency, ensuring their movements are perfectly synchronized. A conveyor belt can automatically slow down if a robot further down the line is falling behind. This level of real-time machine-to-machine communication is only possible when the processing happens locally, right there on the factory floor. It makes the entire production process faster, more flexible, and safer. Furthermore, edge computing is crucial for quality control. High-resolution cameras on an assembly line can inspect products for tiny defects as they move past. An edge AI system can analyze these images instantly and identify a flawed product, signaling a robotic arm to remove it from the line. Doing this with the cloud would be far too slow to keep up with the speed of modern manufacturing. By bringing the eyes and the brain of the quality control system right to the assembly line, companies can ensure higher quality products, reduce waste, and operate more efficiently than ever before. Edge computing is set to transform entertainment and gaming. Latency is the ultimate enemy of online gaming. Edge computing offers a solution by cutting down the distance data has to travel. This makes cloud gaming as responsive as a local console without expensive hardware. This extends beyond traditional gaming. Think about large-scale interactive experiences. Imagine live sports events with augmented reality stats overlaid. Processing happens locally on edge servers. Edge servers can also improve streaming video by caching content. This reduces buffering and improves video quality. It's a smarter way to distribute entertainment, ensuring it gets to our screens faster and with higher fidelity. We've seen how edge computing works. Let's break down the big benefits. The first advantage is speed. By processing data locally, edge computing slashes latency. This speed unlocks futuristic applications, enabling capabilities that were physically impossible with a cloud-only model. It's also about bandwidth. Billions of connected devices generate a tsunami of data. Edge computing acts as a smart filter, processing data locally to decide what's important. This reduces data traveling over the network, freeing up bandwidth. This efficiency improves reliability. Edge systems aren't dependent on a stable connection, making them more robust. Speed, efficiency, and reliability are the core advantages of edge computing. Beyond speed, edge computing offers another massive benefit: privacy. Traditional cloud setups constantly send your data to third-party servers. This includes voice commands, video footage, or location data. You're trusting companies to keep your data safe, but data traveling across the internet creates vulnerability. Edge computing changes this by keeping information local. Smart speakers understand commands without sending audio to the cloud. Security cameras identify deliveries without streaming footage to remote servers. Processing data locally minimizes how much personal information leaves your control, enhancing security. Reducing data transmission reduces opportunities for attacks. Decentralized systems are harder to take down. The less your data travels and is stored, the smaller the attack surface. Edge computing provides a powerful tool for a more secure, privacy-respecting digital future. Edge computing sounds amazing, and it is, but it's not without significant challenges. It's a much more complex system to design and manage than a centralized cloud. Companies now have to deploy and manage potentially millions of smaller distributed edge nodes in homes, cars, factories, or cell towers. This creates a logistical and maintenance hurdle. Security also presents new challenges. It creates millions of new potential entry points for hackers. Every edge device is a potential weak link. Securing this vast distributed landscape requires a whole new approach to cybersecurity. The initial investment can be substantial. edge devices have limitations on processing power, memory, and energy consumption. Finally, there's a lack of standardization. Different companies are creating their own platforms, hardware, and software protocols, making it difficult for devices to work together. Let's bring it all together. We've journeyed from the cloud data centers to the processors inside our devices. Edge computing is a necessary evolution, solving the problem of speed and distance. As our world gets filled with more and more connected devices, the old model of sending everything to a central brain just doesn't scale. Edge computing is the logical next step, a shift to a distributed intelligence. This isn't about replacing the cloud, but augmenting it, creating a powerful partnership. The edge becomes the rapid response team that handles immediate tasks with lightning speed. It allows our technology to react at the speed of life. It promises a world that is more responsive and efficient. Ultimately, understanding edge computing is about understanding the direction our entire technological world is heading. It's a quiet revolution happening right now. It's the inevitable next chapter in the story of computing. So there you have it, that's edge computing demystified. It's all about bringing the brain closer to the body, enabling our devices to think and act for themselves with incredible speed. It's a powerful idea that solves the cloud's biggest weakness and unlocks a future that feels more like science fiction. From the way you shop, to the way you play games, to the safety of our future roads, the edge is quietly redefining what's possible. It's a complex topic for sure, but I hope this breakdown made it all click. The next time you hear that buzzword, you'll know it's not just jargon. It's the blueprint for a faster, smarter, and more private connected world. We've covered a lot today, and I really appreciate you sticking with me through it all. My goal on Tech Curiosity Stream is always to peel back the layers on the tech that shapes our lives, and hopefully we've done that today. If you found this video helpful or interesting, do me a favor and hit that thumbs up button. It really helps the channel out. And if you haven't already, now is the perfect time to click that subscribe button and ring the notification bell so you don't miss out on our next deep dive. We're always exploring the most exciting frontiers in technology. We're just scratching the surface of what's possible with technologies like 5G, AI, and the Internet of Things, and edge computing is the critical thread that ties them all together. As these systems become more integrated into our daily routines, being curious about how they work is more important than ever. It empowers you to be a smarter consumer and a more informed citizen of the digital world. I'd love to hear your thoughts, so drop a comment down below. What part of edge computing excites you the most? Is it the instant smart home, the lag-free gaming, or something else entirely? Thanks again for watching and for being part of the Tech Curiosity Stream community. Your curiosity is what drives this channel, and I can't wait to explore another piece of amazing technology with you in the next one. We've got a lot more to cover, so stay tuned. It's been great breaking this down with you. See you in the next video. Until then, stay curious.